Okay, this question, uh, we look at this circuit. The first question says, name the electrical device X. Well, you can see two arrows going in. So this device actually a LDR. Now you cannot write just LDR. Please write the full name like dependent resistor. Okay, 60 ohm resistor is an ohmic conductor. What is an ohmic conductor? That means it obeys Ohm's law. All right, it means it obeys Ohm's law. That means Ohm's law means V equal IR. If you remember the formula that you have learned, this is actually the formula that comes out from Ohm's law. All right, so basically you just need to how to say explain this. Right, actually what it means is when you draw your graph of V against I or I against V, you'll get a straight line. So it's I. Okay, so basically it's saying that the potential difference is proportional or directly proportional to the current flowing. Okay, so let me find a box, insert text box. Okay, it's just one more question now. So basically it's just the definition. All right, the potential difference across the device is directly to the current flowing through the device. Okay, provided temperature is constant. Okay, stop. Because if the heat go out, then everything changes. Okay, that's what I mean ohmic conductor. All right, now when the magnitude, when the potential at terminal P and Q are 4.5 degrees, 4.5 volt and plus negative 4.5 volt, state the magnitude of the voltmeter reading. If this is positive 4.5 and this is negative 4.5, so what is this potential difference? The potential difference will be 9 volt. And this V is measuring when the state the magnitude of the voltmeter reading. Okay, so the answer is basically add them together is 9 volt. Because this is positive 4.5, that means the current is flowing in this direction. When the current is flowing in this direction, this thing here is good as having no resistance, because in this direction it's almost zero. So the current will flow here, and then flow through here. So you will not flow through the 60 ohm resistor. So it's as good as saying the 60 ohm resistor is not there. So the whole voltage, the whole PD will be across device X. So whatever is the PD between P and Q will be the PD between X. So that's why it's 9 volt. Okay, then now if we reverse it, the potential at P and Q are then reversed. And if device X is subjected to high temperature and extreme low intensity, calculate the magnitude of the voltmeter reading. Wow. High temperature and extreme low density. Okay, let me look at all the numbers that they give. The resistance of device X ranges from 40 ohm to 140 ohm. If wait, what is it giving me? High temperature. But why would I care about temperature? This is a light one. So this is extremely low light intensity. That means I have extremely high resistance. That means my resistance will be 140 ohm. 140 ohm. And now because I have reversed the voltage of the terminal, now current flows from Q to P instead. So as current flow from Q to P, it cannot flow through here. This part that I circled, it can only flow through the 60 ohm resistor and through device X. So it's your normal potential divider setup. So now this is 140 and that is 60. So we can actually do that. Okay. The voltmeter reading is across the LDR. LDR voltage, ohms is 140 over the total ohmage is 140 plus 60. Sorry, total resistance. And then you multiply by the total voltage that you are being distributing. So the total is 9. Okay, just make a calculation of this. And you'll get 6.3 volt. Yeah. Okay. This question is done. That's it. All right. This is a semiconductor diode. That means you only allow current to flow in one direction. In the other direction, resistance is so high that current cannot flow through. That's an ideal diode. Oh, basically that's it. Next. Circuit diagram of a lighting system with two identical light bulbs. So where's the light bulb here? One Q here and one P. Describe how the brightness of light bulb Q changes as the pointer moves from X to Y. X to Y. Okay, so when it's at X, can you see that it doesn't go through the whole thing at all? It actually goes through the light bulb here like that. So there is no resistance here when it's at X. So if it's no resistance here at X, oh, this is a double side one. So current here, current there. So it should decrease. Because as it move from X to Y, the resistance increase. When the resistance increase, when the resistance increase, the brightness will decrease. Oh, explain your answer. Okay, let me just write my answer first. Because I don't want to type. The phone is easy. Brightness of there. Describe how the point from P to Q switch. Wait, oh my! Switch S1 closes. Switch S2 open. Correct. Okay, brightness of Q decrease to 0. Decrease. Just decrease, not to 0, decrease. Yeah, it decreases. Explain your answer in A part 1. The potential difference is 20 volt. When it's here, means it's just like that. You'll get the whole thing. But when it goes to Y, it becomes a potential. In fact, it was already a potential divider setup. So you'll get what is the. Do we know what's the total highest resistance? We don't know. So you just become less bright lah. Okay. Initial voltage. The voltage determines the current. Initial voltage across light bulb is 20 volt and gradually decrease as as X move to Y. As no what? No no. As pointer. As pointer. Move from X to Y. Okay, can. Explain how the brightness of light P changes. B part 1. Explain how the brightness of light bulb P changes as the light intensity of the surrounding decrease. Oh, I think you all cannot see it. Let me decrease the magnitude. Okay, intensity of the surrounding decrease. As the intensity of the surrounding decrease, this is a LDR. LDR, the light intensity decrease, the resistance will become higher. If the resistance become higher, the PD across the LDR will increase. So the light bulb will become brighter. Yeah. Okay, wait, I think now I see more clearly. Brightness of Q decreases to zero. Because by the time this resistance comes to here, there will become a short circuit. It will not flow through a light bulb anymore, it will flow right through. Right? Because when it become like this, it will become like that. Okay, the current will not flow through Q, but it will flow straight through this wire. You'll become something like a setup like this. So that you drop to zero. Drop to zero. Brightness will drop to zero. 20 volt and decrease to and gradually decrease to zero as the pointer move from X to Y. Yeah. All right, let's continue. Sorry. Let's bring to this. Explain how the brightness of P changes the light intensity of the surrounding decrease. Okay, so just going to do in cause and effect. S. Oh no no. Type. Let me erase this. As light intensity decrease, resistance of the LDR increases. Thus, the PD of the PD across the LDR increases. Since light bulb P is in parallel with LDR, the PD is the same because they are parallel each other. The PD across P increases. Since the PD increase, brightness increase. Okay, done. Part 2. The potential difference across light bulb P is 6.5, emitter is 0.4, calculate the resistance of the fixed resistor R. This is 6.5. 6.5, 0.4. This is 6.5, this is 0.4A. Resistance of the fixed resistor. So what is this? Okay, we know the total voltage is 20. Very easy way to find out. We can just don't need to do potential divider. We can just minus away the voltage across P. Okay. Huh? Is that the V or the wait? 6.5 is the one. Oh, it's the volt, not the ohm. Irritating. Okay, so we know PD across R is equal to 20 minus 6.5 equal to 13.5 V. Okay, sorry, I entered for resistance. Did I just enter something? Okay, no. Resistance of R equal to 13.5 over 0.40 equal 33.8 ohms. Yeah, just do the math. That's it. V equal R using V equal R. Yeah. And this one is just minus away because potential divider setup. So here is 33.8 ohms. Is there an advantage of using LDR instead of potential divider in the lighting system? LDR, you know, if it's a potential divider, someone has to manually do it. You need to shift the pointer, like on the right side. Yeah, this side is you need to shift the pointer, but this is automatic. When it's dark, then the lamp will light up. Okay, I think that's the advantage. Okay, just gonna write below. Brightness of P using the LDR changes or keyword automatically as compared to Q, which requires manual adjustment. Okay, that's for C. And next question. Show appliances R and S connected to a 240 volt main supply. Apparent R has a result 80 ohms, S have a resistance of 40 ohms. Draw lines to complete the connection of the earth wire to the appliance. Very simple. It should be touching the metal casing. Right, so they never say draw what kind of line, just draw very normal line. Maybe I'll use a different color so it's more obvious. Red color. So it should be touching the metal casing. It should also be touching the metal casing of appliance R. Okay, that's it. Oh, socket splitter. So you should go through a socket splitter. If not, how is it going to touch? Okay, wait. Let me see. I don't know whether they're going to penalize you if you don't follow the socket splitter. Alright, so maybe like that. Go through here, touch. Yeah. Why explain why a fuse is placed on a live wire leading into appliance instead of the neutral wire leading on the appliance? Oh, this is a very common question. Please make sure you know how to answer. Okay. Please make sure you know how to answer. Huh? Just gonna type it out. Insert. Mm, the fuse is connected on the live wire so that after it blows or blown due to excessive current, the appliance will not be at high, and this high, let's emphasize, high voltage. You can also call it live, or will not be at high voltage or live voltage. Okay, determine the energy in kilowatt hour that the appliances use after they switch on for a whole day. One whole day, so we assume 24 hour. But before that, we need to calculate the watts. Okay, so it has a 240 main. The resistance is R. Appliance, which appliance? R. Okay, R. Say this one. It has a resistance of 80, and that's all we know. Okay, very little information. So the only way we can do it is using V square R, V square over R. So power is equal to V square over R. How do I get this? P equal IV. This is a basic equation that I asked you all to memorize. So if we insert substitute our Ohm's law equation into this to replace I, because our Ohm's law is V equal to IR, so I is equal to V over R. So if I sub this in here, this I will become V over R times V. So you'll get V square over R. Okay, so that's how you get V square over R. And then your V is 240, and then we're going to square it, divide by 80. Divide by 80. And that will give you 720 watts, which is 0.72 kilowatt. Remember, we want to calculate the kilowatt hour, so we must change the kilowatt hour, and then we must multiply with the number of hours we are using it. Since they say we are using it for 24 hours, so 0.72 kilowatt times 24 hour, then you will get 17.3 kilowatt hour, and this is your answer here. State if a 9 ohm, ampere fuse is placed at the point marked X on the live wire is sufficient. Support your answer with calculation. You would have to find out what is your operating current. That's very important. Where's X? X is here. This is the main, that one ahead of the socket splitter. That means you have to have both current from appliance S and appliance R. Then we need to calculate how much current is appliance S using and how much current is appliance R using. So in this case, we'll use V equal IR for appliance R and S, right? Yeah, R, like 80 ohm. For R, V equal IR. Okay, appliance R, APP. V is 240, I is unknown, R is 80. So my I is 3.0 ampere. For appliance S, V equal IR, 240 equal I times 40. I is equal to 6.0 ampere. So the total current flowing through the point that they call X, mark X, should be 3 plus 6, which is 9.0 ampere. That means this is the operating current that is passing through X. If we were to put the 9 ampere fuse, it will not be enough because it will melt immediately when you switch it on. So it's not enough. We would need to be higher. Okay, need a statement for it lah. Uh, Rating need to be higher than 9 ampere. Okay, next question. If an electric circuit, what is meant by current flow in a circuit? Okay, very simple. Just throw in a definition of current. Right, it's the rate of flow of charges and electron in the circuit. Okay, current is the rate of flow of charges per unit time. Oh no, rate already is per unit time. Charges in a circuit. Keep it short and sweet. All right, 1 mark. Determine the current in the lamp. Now, if you look closely, uh, this is 200 ohm. You have a variable resistor and you have a lamp. The graph of current against potential difference. The potential difference across the lamp is 2.5. Okay, that's the key, man. 2.5. So go up 2.5. You see here. If you go up 2.5, and then you use the graph, you see that the corresponding current is 0.05 ampere. So what is the current in the lamp? The current in the lamp is 0.05 ampere. Okay. All right, next. Determine the current in component X. This one, what is the current component X? If the current in the lamp is 2.5, if the current in the lamp is, no, the current in the lamp is 0.05 ampere, and the resistance, do we know the resistance? We don't know anything. What is the current? But we can find the voltage, do we? Yes, it's 2.5. It's 2.5 is parallel, means this resistance is also 2.5 volt potential difference. We can use VYR, where our V is 2.5 and then our R is 200 ohms. And you can find out I. Your I, use a calculator, you will get 0.013 ampere. sketch the graph for the 200 ohm resistor. Okay, it's a resistor, so it should follow ohmic law. Okay, Ohm's law. It should be a straight line, but I need 200 ohms. That means the gradient should be 1 over 200 because this is an IV graph. Or actually, I can just use this value. 2.5 and 0.013. 2.5, 0.013. It's around here. I would prefer a greater number though, but I don't think it's going to make much difference. So if I were to draw a graph for the 200 ohm resistor, 0.013 is about here. And I want a straight line. Okay. Do I have a straight line that I can insert? Okay, I want a straight line. Yes, and this will be my straight line. Okay, this will be my graph for the 200 ohm resistor. And then component X. Oh, take note, please, it should pass through origin. Yeah, because when V is 0, I is 0. Okay, next question. Part C. Draw the symbol for thermistor. Okay, as you have learned, thermistor is actually a resistor that responds to temperature. So you have this part that is flat and then it goes up. The temperature around the thermistor increases. Describe what happens to the resistance and potential difference across the thermistor. Now, we are in your syllabus. We will only learn negative relations potential. So if the temperature increase is always the reverse. The temperature increase, your resistance would decrease. Where's the box? Okay, here. Okay, what will happen? Resistance will decrease. And when resistance decrease, the potential difference should also decrease because of potential divider. They are replacing that, right? Component X is a variable resistor, correct? Because this is a potential divider setup. If this thing decrease resistance, you also have a lesser share of the voltage. Therefore, potential will decrease. Okay, a typical hair dryer comes with a 2-pin plug. There's a fuse found within the plug. Describe how the fuse protect the wires in the hair dryer. Okay, quite a simple question. So the fuse will blow. And the current is above the fuse rating. This will cause the circuit to be open, or you open the circuit. Calculate the current in the hair dryer. So again, very easy. P go to IV. So 1500 equal I times 240. So I will be equal to 6.3 ampere. Okay, suitable rating. Something higher than 6.3. All right, something higher than 6.3. State anything, maybe 7, 8, or I prefer 8, so I'll just say 8 ampere. Okay, anything that is higher than 6.3 but not too high, limit maybe until 10. If you say 13, 20, that's really too far off and you will not be useful in protecting the circuit. Okay, next, the hair dryer does not contain an earth wire to connect to the plug. State the feature of the hair dryer which ensures that it is safe to use without an earth wire. Now, regulation states that as long as the casing is metallic, it's a conductor of electricity, you need the earth wire. So the feature which ensure that it's safe to use, that means the casing must be a insulator of electricity. Okay, the hair dryer outer casing must be made of plastic or any e- electrical insulator, insulating material. That's it. Okay, we reached the end. Thank you for watching.